Good day everyone. I am Jumo Bitangkihai from BSEE 2A. Today I'm going to present to you a problem from our lesson 14, which is the problem 7.103, presented by yours truly. So the problem is a spherical pressure vessel of 750 millimeter outer diameter is to be fabricated from a steel having an ultimate stress of sigma u equals 400 megapascals or MPa. Knowing that a factor of safety of 4.0 is desired and that the gauge pressure can reach 4.2 megapascals, determine the smallest wall thickness that can be used. So first, we're going to think about the strategy or the approach that we're going to use. So the approach that we're going to use is that we will use the equation 7.36 and give an ultimate stress to find the smallest wall thickness of the shaft. So first, we're going to have a given. Of course, we're solving a problem here. So we should state a given so that we can easily solve the problem. First, we're going to take the inner radius. That will be, the equation for that will be radius equals diameter over 2 minus t. And then we are going to use the 0.75 that was our approach. That is r equals 0.75 over 2 minus t. So that will be 0.375 minus t. So that will be our inner radius. The next will be the maximum stress. So the maximum stress is sigma maximum equals PR over 2T. So we're going to look now for the allowable thickness. So Fs is equal to 2T sigma U over PR. That will be the equation that we're going to use. Next is, and then transpose, that will be 2 sigma UT equals Fs times PR. Then we integrate, we will substitute those symbols or those given by the numbers that we have. So that will be 2 times 400 times 10 to the power of 6 PA T times T equals 4 times the product of 4.2 times 10 raised to the power of 6 pascals times our radius, which is 0.375 minus t. Then next, we'll solve that. That will be 816.80 times 10 raised to the power of 6t equals 6.30 times 10 raised to the power of 6. As we solve this, we're going to, transfer the 816.80 times 10 raised to the power of 6t to the other side. So by doing so, we should divide 816.80 times 10 raised to the power of 6t to both sides. So then, what will be left on the left side will only be t. So this is the answer. So the answer will be t equals 10.71 times 10 raised to the power of negative 3 meters. So the unit here is still in meters. So we're going to multiply it by 1000 because the unit that we're going to use is millimeter. So that is what we're going to find. So if we multiply this by 1000, it will become 7,700 7,710 times 10 raised to the power of negative 3. So then we're going to transfer this out. We're going to convert this into a proper decimal number because we have the negative 3 as an exponent because this is a scientific notation. The answer for that will be T equals to 7.721 millimeter. So that will be our allowable small thickness. So therefore, the allowable small thickness of the wall is only up to 7.71 millimeters. So that will be all for this problem. It's quite short, so the video is also short. So thank you very much for watching and see you next time.